How to build the SensorBox. Here we are looking at the basic software setup. The video is intended to be used with our documentation that provides detailed step-by-step instruction with tricks and tips on how to build the SensorBox. We use the sensors and processing board without the cover for the software setup. Connect the power push button to the quick disconnect terminal connectors. Connect the HDMI monitor directly to the NVIDIA Jetson development board. And connect the USB-C charger directly to the USB-C power bank. Let's start with the software setup of the NVIDIA Jetson Xavier NX. Connect the micro USB port to the USB port on the host computer and put the USB dongle from the keyboard and mouse in the free USB port. Make sure that you have inserted the micro SD card. Use a jumper wire to place a jumper across the force recovery mode pins 9 and 10 on the button header J14. Power on the SensorBox using the push button. The NVIDIA Jetson now comes up in force recovery mode. Once powered on, you can remove the jumper wire. Join the free NVIDIA Developer Membership Program to get access to all NVIDIA resources. Use the NVIDIA SDK Manager to flash the NVIDIA Jetson and to set up the development environment on the host computer and the NVIDIA Jetson. The SDK Manager can be downloaded for free from its website. Make sure that you have cloned our SensorBox repository from GitHub. We already downloaded a copy of the SDK Manager. Install the SDK Manager. Run the SDK Manager to flash the NVIDIA Jetson and to set up the development environment on the host computer and the NVIDIA Jetson. Time to get a coffee. This will take some time. Configure the Ubuntu System Configuration Wizard on the NVIDIA Jetson and make sure the software is updated. Enter the username and password for the NVIDIA Jetson. Once the installation is completed, power off the SensorBox. Now we don't need the host computer anymore, and we can work directly on the SensorBox. Power on the SensorBox by using the push button. First, set up Wi-Fi. Then the Bluetooth keyboard and mouse. We use Jetson hacks instructions and scripts to make our system run from the SSD drive. First, format the SSD drive. You can clone the scripts for free from Jetson Hacks GitHub repository. We already cloned the repository. Just run the script to copy the rootfs from the SD card to the SSD drive. And then run the script to set up the service that switches the rootfs to the SSD drive after booting. Reboot for changes to take effect. Set up the 15 watts 6 CPU power mode. Access the power monitor on the NVIDIA Jetson development board. For the total 5-volt system, CPU and GPU combined power, and the SoC power rail. Use NVIDIA's TegaStats utility to monitor processing, memory, temperature, and power. We use Ravello Bongi's JTOP Python package to monitor the Jetson platform. You can install JTOP for free using pip. Reboot for changes to take effect. JTOP provides a nice graphical system monitor. We put together detailed instructions on how to do the basic software setup for all the components. Running a single script performs the installations for all the components automatically. Alternatively, we created Docker files for all components. We built a Docker image with the installations for all components. The udev rules need to be installed on the Docker host. After the installation, reboot. We run our Docker container to demonstrate the basic operation of the components. We can see a list of our video devices using v4l utils. We got two ArduCam Sony IMX219 RGB cameras. They work out of the box with GStreamer. We got a FLIR Lapton 3.5 thermal camera. Using the GroupGATS Pure Thermal 2 module, it works out of the box with GStreamer. Note that the thermal images are upside down because that is how we installed the camera. We installed GroupGATS modified version of the libUVC, which can be downloaded for free from its website. GroupGATS provides a suite of UVC capture examples which can be downloaded for free from its website. Here we print the software and hardware version and a min-max temperature example. GroupGATS also provides an open source application, GetThermal, which can be downloaded for free from its website. We got an Intel RealSense D435i RGB-Depth camera with an integrated IMU. We installed Intel's libRealSense which can be downloaded for free from its website. Here we use the RealSense viewer to interface with the Intel RealSense. Let's take a look at the software setup of the Sparklin Redboard Turbo, an Arduino Zero at its heart. We installed the Arduino IDE, which can be downloaded for free from its website, with the Arduino SAMD board add-ons for the 32-bit ARM Cortex M0+. We installed the Sparklin SAMD board add-ons for the Redboard Turbo, which can be downloaded for free from its website, and which we modified to work on an ARM64 architecture. It's simple to run the Arduino IDE. We created and installed a sketch to scan the I2C bus for the addresses of our sensor suite. To run it, simply upload the sketch. We got a Maxbotics HR LV Max Sonar EZ4 Ultrasonic rangefinder. We created and installed a sketch to read the range measurement over the UART. We got a Sparklin Neo M9N GNSS receiver. We installed the Sparklin uBlocks GNSS Arduino library, which can be downloaded for free from its website. We created and installed a sketch to read the data from the GNSS receiver. We got a Sparklin LPS25HB pressure sensor. We installed the Sparklin LPS25HB Arduino library, which can be downloaded for free from its website. We created and installed a sketch to read the pressure and temperature from the sensor. We got a Sparklin ICM20948 IMU. We installed the Sparklin ICM20948 Arduino library, which can be downloaded for free from its website. We created and installed a sketch to read acceleration, angular rate, magnetic field, and temperature from the IMU. We got Sparklin LSM9 DS1 IMUs used with the RGB cameras. We installed the Sparklin LSM9 DS1 Arduino library, which can be downloaded for free from its website. We created and installed a sketch to read acceleration, angular rate, and the magnetic field from the IMU. We got a Sparklin TMP102 temperature sensor. We installed the Sparklin TMP102 Arduino library, which can be downloaded for free from its website. We created and installed a sketch to read the temperature from the sensor. We got a ZIO INA219 current and voltage sensor. We installed the Adafruit INA219 and the Bus.io libraries, which can be downloaded for free from their websites. We created and installed a sketch to read the power measurements from the sensor. Let's take a final look at multiple outputs at the same time.